Hey there, back from my week off. As you can probably tell, my leg is doing much better and I'm able to run again. I've missed exercising. Speaking of exercise, as you may recall, last time I was shown a rather, let's say, ignorant comment from the leader of our neighbors to the south regarding how humans work. I'm off next week. I just hope nobody says anything incredibly ignorant that has to wait until I get back. Really? Oh, son of a... I figured this week we'll talk about it, hopefully explain where you made a mistake. Let's do this. Better. So, as I mentioned, President Trump refrains from exercise because he thinks humans only have a set amount of energy in them and physical work depletes it. I will concede that human beings have energy in them. We need energy to keep our bodies together and function, but we weren't simply born with a finite amount of energy. Life is defined by several qualifiers. It must be able to resist entropy, be created through reproduction, respond to the environment, and obtain energy through metabolic processes. The last on there, obtain energy through metabolic processes, is where he seems to not understand basic biology. The metabolic process works like this. Grab a coffee. This might take a while. Now, metabolism is the sum of all energy-producing and energy-using activities in the living organism. Basically, the chemical reactions that occur to sustain life. There are two kinds of metabolic pathways. Anabolic pathways, chemical reactions that build complex molecules from smaller units, and catabolic pathways, chemical reactions that break down a large compound into smaller units in energy. Catabolic processes have nothing to do with, these. Apart from also having a metabolism as well. Metabolism never stops. At least, when it stops, the organism is dead. Living creatures, from bacteria to blue whales, all metabolize with the same basic processes. Food and fuel is broken down into base constituents that feed chemical reactions that generate a molecule called adenosine triphosphate, or ATP. ATP is known as the molecular currency of intercellular energy transfer. Remember that. I'm going to be using that acronym a lot very soon. Breaking phosphate bonds releases a lot of energy that cells can use to generate heat, movement, neural signaling, basically everything a living body does. To break it down, for animals, plants have different inputs, but the output is always ATP. Let's look at both pathways. Catabolic pathways. Catabolic pathways break down complex compounds into molecules the organism can use to generate energy. Fuel, in our case food, is eaten. Carbohydrates, starches and sugars, are broken down enzymatically into simple sugars, lactose, fructose, sucrose, which are in turn broken down into glucose. Glucose metabolism includes glycolysis. One glucose molecule becomes 2 ATP, 4 high-energy electrons, and 2 pyruvate or pyruvic acid molecules. Conversion of pyruvate into acetyl coenzyme A, which requires oxygen. 2 pyruvate becomes 1 CO2, 2 high-energy electrons, and 2 acetyl coenzyme A molecules. The citric acid cycle. 2 acetyl coenzyme A becomes 2 ATP, 16 high-energy electrons, and some other compounds. And finally, the electron transport chain in the mitochondria uses all these high-energy electrons to generate 26 to 28 ATP and some water. Fats are broken down into glycerol and free fatty acids. Free fatty acids are oxidized into acetyl coenzyme A and enters the citric acid cycle. Complete breakdown yields carbon dioxide, water, and ATP. Proteins are broken down into amino acids, which can be used to generate energy, but it's not very efficient. Basically, breaking those down is the last resort in starvation. Amino acids are preferentially used for anabolism. Anabolic pathways. Anabolic pathways, otherwise known as biosynthesis, is a vast number of specific pathways that use glucose, fatty acids, and especially amino acids to make complex molecules that are used for construction or put into storage later. Glucose and energy become glycogen, a type of starch that is stored in the muscle and liver for use as energy reserve, and some complex carbohydrate synthesis for building glycoproteins. Acetyl coenzyme A and energy become fatty acids and triglycerides for storage in fat cells. This is how too many carbs turns into fat. Breakdown of carbs results in acetyl coenzyme A, and if there's an excess, it gets turned into fat and stored. Some fats are used in the construction of cells. For instance, cell membranes are made of fatty acids. Amino acids and energy become a staggering variety of specific proteins, lipoproteins, and glycoproteins that make up a living organism's body. Or, to put it simply, metabolism is always churning along. We eat, We break down food into energy, and we use that energy to do our thing and build ourselves. If the human body was born with all the energy it's ever going to get, we would either die rapidly or weigh hundreds of thousands of pounds at birth. Any woman who's ever given birth, I think, would be grateful that we aren't. So as you can see, we are not limited to the energy we were born with. We are constantly taking in sustenance from plants and animals around us. We take that food matter and convert it into energy. In fact, how we take in food is one of the things that resulted in humans thriving. Being able to cook our food meant we could digest and process it more efficiently, giving our bodies, and especially our brains, the energy they need. As a tool-using species, we need our brains to manipulate the world around us in a beneficial way. You may notice if you have to do a lot of thinking, studying or whatnot, you can get hungry fairly quickly. That's because our brains demand a lot of energy to function correctly. This resulted in a bit of a trade-off. As our bodies became more accustomed to taking in cooked meat, we lost the ability to fight off the parasites and bacteria that would grow in uncooked foods. That's why we now need to thoroughly cook much of our food for safety reasons. Take a parasitology course. You will never have a rare steak again. We have reached the point where food is so easy to come by, at least in the first world, overconsumption is very easy to accomplish, hence the obesity rates in developed countries. We were designed hundreds of thousands of years ago to try to find as much food as possible and even store it within ourselves. Most hunter-gatherers did not carry fridges around with them. But in the last century, as food has become so easily and consistently available, our instincts, which serve us well to get where we are, cause many to overindulge. That's why it's very hard for people to lose weight. Our bodies evolved at a time and place where provisions were not abundant. We have changed the environment to give us much easier access to food, and our bodies are simply not adapted to that yet. This does not get into those whose bodies, for whatever reason, are unable to process food properly and have an even more difficult time maintaining a desired weight. Your president was right when he said that exercise will deplete the body of energy. But, as we learned earlier, we are able to replenish the body with new energy by taking in calories and metabolizing them into energy. Exercise also has the benefit of strengthening the body. I try to jog several miles a day. It has the twofold bonus of helping me get rid of excess calories and help build up my endurance and cardiovascular system. I am seen regularly by a cardiologist who has noticed my heart and blood pressure are doing much better than when I had a very sedentary lifestyle. My increased endurance means I no longer get winded doing simple tasks, and I'm better able to please my wife in bed.
No, you still can't.
Yes, you can overdo exercise. Too much of anything is bad for you. That's literally what too much means. People can ruin their bodies if they push them too hard. There are many stories of athletes wrecking their bodies by running them beyond their limits. So when you do exercise, figure out what your body can handle and make sure it's not too much. In other words,
Check yourself before you wreck yourself. Check yourself before you wreck yourself. Come on, check yourself before you wreck yourself.
but in general, as you work muscles, it helps them get better at doing what they're supposed to do, becoming stronger. Really? We're ending on a masturbation joke? I thought we were better than that. Guess not. Let's do this!
Oh God.
Alright. Yeah. Try that again, maybe a bit slower speed.
Yeah.